Hello students and welcome back to my channel. Today I have come up with questions based on thermodynamics. Okay, these questions have been asked on the 30th January, both morning and evening combined, 2023 JEE mains. Okay, we have altogether around four questions, 4 to 5 questions. Let us solve them one by one. So here comes the first question. The pressure P and temperature T relationship of an ideal gas obeys the equation Pt square equal to constant, the volume expansion coefficient of the gas. Now here students, we have to understand what is the meaning of volume coefficient of gas. This volume coefficient of gas, it is nothing but you can denote it by alpha or beta, anything is okay. Volume coefficient of gas is the fractional change in volume per unit change in temperature. Okay, it is defined as the fractional change in volume per unit change in temperature. In other words, you can write it as 1 by V dV by dt. So this is what we have to find. Okay. So if you can get a relation between volume and temperature for the process, then you can differentiate both sides and get the result. Here you can see the process has been expressed in terms of pressure and temperature. So let us eliminate pressure and in terms of volume. Let us keep the temperature as it is, but we have to eliminate the pressure here in terms of volume. So finally we get an expression in terms of volume and temperature, and accordingly we can differentiate to get this result. Always remember, while solving any questions based on thermodynamics, please remember equation of state. Okay, I guess if I'm not wrong, at least 6 to 7 questions out of 10 will require the usage of equation of state for an ideal gas, that is PV equal to nRT. Now, what we have been given is Pt square is a constant. Is it? This is what is given. Now, pressure can be written as nRT by V as per equation of state for an ideal gas. Okay. So, accordingly, you have T cube is equal to some constant into volume. T cube is equal to this nR will be merged in the constant. They'll get merged in the constant, and we'll have a new constant k. Now, taking log and differentiating both sides. So first to take log. So once you take log, you'll have something like this. It can be any log, particularly maybe natural log is more better. So derivative of log t is 1 by t and dt. For a constant, derivative is 0. This is this. Okay, sorry. So from here you can see dv by dt by v will be 3 by t. Can you see dv by v? Just bring this dt to below this. So you are left with 3 by t. So D option is the correct answer. Moving on to the next question. Heat is given to an ideal gas in an isothermal process. Remember, isothermal means there is no change in temperature. If there is no change in temperature, there is no change in internal energy, because change in internal energy is a function of temperature change, isn't it? It's a function of temperature change. So if there is no change in temperature, there is no change in internal energy. And if there is no change in internal energy, then whatever be the heat given, that will be utilized by the system to do work against the forces due to external pressure, or pressure due to external forces. So now let us see, one level heat energy of the gas will decrease. Internal energy will not change as we have discussed. So this is wrong and this is also wrong. B option. Coming to statement C, internal energy of the gas will not change. Yes, this is true. The gas will do positive work. Naturally, if heat is supplied to the gas will do positive work, because if delta Q is positive, W has to be positive. So this is also correct. The gas will do negative work. This is wrong. So C and D are the correct statement. So B option will be the correct option. C and D. Moving on to the next question. Below are given below are two statements. One is labeled as assertion A and the other is labeled as reason R. Efficiency of reversible heat engine will be highest at minus 273 degree Celsius of cold reservoir. This is true. The efficiency of Carnot engine depends not only on temperature of cold reservoir but depends on the temperature of hot reservoir to induce membrane. This is also correct. Now, why assertion is true? You see, because if you substitute T2 equal to 0 here, the efficiency will be 1, and that is the maximum efficiency. Percentage wise, it is 100%. 1 means 100%. So, naturally, any engine cannot have efficiency beyond 100%. So, maximum efficiency could be 1, that is 2. So, both are correct. Assertion A is correct, reason R is correct, and reason R is the correct explanation for. So, both A and R are true, and capital R is the correct explanation. So, C option is the correct option. Okay. Right. So remember, minus 273 degrees Celsius corresponds to 0 Kelvin. Here the temperatures have to be substituted in Kelvin. So when you put T2 equal to 0 Kelvin, so eta will be 1. That is the explanation. Now coming to next question. A flask contains hydrogen and oxygen in the ratio 2 is to 1 by mass at temperature 27 degrees Celsius. The ratio of average kinetic energy per molecule. We have to find the average kinetic energy per molecule of hydrogen and oxygen. Now, students, you know that the average kinetic energy, okay, per degree of freedom and per mole is this. Per mole. If it is per molecule, you have to divide by the Avogadro's number because that will give you the average kinetic energy per molecule. So R by N is K. So this will be KT. Okay. So that means the average kinetic energy per molecule. Remember K is Boltzmann constant. Okay. This is the Boltzmann constant. So the average kinetic energy will depend on two things, that is degrees of freedom and the temperature. Since both are diatomic gases and temperature is not too high, 27 degrees Celsius is not too high. So the degrees of freedom will be 5 each. So F is same for both. Also, both are at the same temperature, namely 27 degrees Celsius. So T is also same. That means they have the same kinetic energy regardless of their nature. Even though both are different, but both are diatomic gases and both are at same temperature. So they'll have the same kinetic energy per molecule. Moving on to the next question. A faulty thermometer reads 5 degrees Celsius in melting ice and 95 degrees Celsius in steam. The correct temperature on absolute scale will be this much Kelvin when the faulty thermometer reads 41 degrees Celsius. Now, students, here, what is the meaning of a faulty thermometer? That we have to understand. It is being called as a thermometer means it is a thermometer. Undoubtedly, it's a thermometer. But why the word faulty is being used for this? Because of the difference in calibrations or the markings, the divisions corresponding to different temperatures, they have been marked incorrectly. Okay, because calibration is not being done in a proper way, so the thermometer has become a faulty thermometer. In other words, it's not giving the correct temperature. It's not reading or it's not showing the correct temperature. So anyway, in such a case, as I discussed in one of my videos, what will be the situation regardless of the markings and all? The expansion will remain same, isn't it? Expansion of mercury will remain same. So suppose at 0 degrees Celsius, this is the value, this is the reading, okay, and at 100 degrees Celsius, the mercury expands till this length, and in general at some T degrees Celsius, it expands to this. Now this ratio, the ratio of these lengths will be same. The ratio of these lengths will be same. So here T minus 0 degrees Celsius upon 100 minus 0 degrees Celsius will be same. Now coming to this faulty thermometer, the melting ice, here it is 5 degree, 5 degree, sorry, the temperature of melting ice is 5 degrees. Don't use degree Celsius or else you'll get confused. Okay. And the at the steam point, that is boiling point of temperature, the boiling point of water, it is 95 degrees. And at a certain point of time, it is measuring 41 degree. So temperature is 41 degree and temperature of melting ice is 5. This is 95 minus 5. This is how we calculate any unknown temperature even with a faulty thermometer. So this we have T, remember we are finding T in degree Celsius. T degree Celsius will be T by 100. 41 minus 5 is how much? 36. So 9 fours are 9 tens are. So T is exactly 40 degrees Celsius. T is 40, sorry, we have to express it in Kelvin. So 40 degrees Celsius means you add 273 to get 313, isn't it? 313 Kelvin. Okay. Then moving on to the next question. We have done with all the questions. That's all students in this video. Thank you so much.